Okay, hello everyone. Today we are going to have tutorial number 4 in database CSEN 501. Let's have a small recap on what we took last tutorial. In last tutorial, we have seen how to map the ERD diagram to the relational schema and how the entity is mapped to a relation and the attribute is mapped to a new column, and how we map the relationships into relation. Okay, in this tutorial we are going to map the EERD to a relational schema. Okay, first, what is the difference between the ERD and the EERD? When we say EERD, we mean that there are super and subclasses in our diagram. There are inheritance and classes that inherit attributes from other classes and so on. So, how we are going to map the super and subclasses to the relational schema or to the relational model? First, we have more than one option in order to map an EERD diagram. Number one, either to neglect the superclasses, okay, and include a relation for each sub with the common attributes. For example, assume that we have a class which called animal. For example, we have class animal, okay, and there is two subclasses, dog and cat, for example. One of the options is to neglect class animal and make two relations, one for the dog and one for the cat, and take all the attributes that is found in this entity and put it once in the dog and once in the cat. So in this case, we are going to neglect the superclass and make two relations for the subclasses, adding the common attributes in each relation. Okay, what is the disadvantage of using such an option? In this case, a lot of repeating common attributes which can cause redundancy. Also, we cannot model the partial condition, in which instance belong to the super only. What if we have a superclass animal, okay, that is not either a dog or a cat? In this case, we cannot keep track of such an animal because we neglected the superclass. So this is one of the disadvantages of using this method. However, this method can be used in other different scenarios. Another approach to map the EERD is to make one universal table with all the attributes of the super and subclasses, okay? And the values will be null if they don't have these attributes. For example, make a relation called animal and put here the attributes of the animal plus the attributes of the dog plus the attributes of the cat. However, in this case, if we have a record of a cat, for example, the attribute of the dog all will be null. So in this case, a lot of values may be null. However, it's still a valid option and can be used. The third approach, which can be used in this case, is one relation for each entity. So in this case, we will have a class called animal, a relation called dog, and a relation cat. So we are going to have three different entities, okay, where the subclass inherits the primary key of the superclass only. For example, if we have here the primary key name, so here we are going to have name which will be a foreign key here, and name, which is a foreign key here that references angle. Okay, so we have three options: either to neglect the superclasses and make a relation for each sub only, to make one universal table and put all the attributes in it, or to make one relation for each entity. Okay, let's take an example to understand this concepts. Okay, in this example, in practice assignment number 4, question number 7, we have an EERD where there is a menu dish, okay, which is a superclass for two subclasses, main dish, side dish, and main dish, which is a superclass for two subclasses, which is diet dish and regular dish. And here we have an entity called ingredients and menu, and there are many relationships between different entities. Let's see how we are going to solve this problem. Okay, let's start with the entities. First we have menu, so we are going to write here menu with primary key ID and name. Okay, and next we have menu dish where the primary key is the name and we have a recipe and calories, where calories is a derived attribute. So in this case we have to state any constraint that is found in this entity. So here we have to mention that this calories will be derived or calculated. So for example, we can write that where menu dish dot calories equal calculated calories. Or if we have an equation to represent it for or something, we can write it as well. Okay, next we have two subclasses, which are the side dish and the main dish. Okay, so we have main dish, which is a subclass for menu dish. So in this case, main dish will have only the foreign key from main dish, which is name, which will be the primary key as well. So here we will have name, which is a foreign key. So we are going to indicate this by a dotted lines, and a primary key as well. Okay, and we are going to state that this references the menu dish. So we are going to say where main dish dot name references menu dish. Okay, same goes for side dish. So we are going to write side dish name, which is a foreign key and primary key, and we are going to state that side dish dot name references menu dish. Okay, and side dish name where name reference menu dish. Okay, now we have two subclasses, which are the diet dish and the regular dish. Both are subclasses for the main dish. So we can make a relation for each one of them. So we will have diet dish with name, which is a foreign key and primary key, and here name references main dish. So we'll state that diet dish dot name references main dish. Okay, in this case we have diet dish and regular dish, which are considered as predicate defined relation, where the relation is defined according to a special attribute, which is calories. We need to state this in our relational model. So we can state here that diet dish, for example, is a predicate defined relation. Using which attributes? Calories, which is the calories, okay, which is the attribute that is inherited from the superclass main dish. So it's a predicate defined relation using menu dish dot calories. As we can see, calories is inherited from main dish, which is inherited from the menu dish, and the same goes for the regular dish. Okay, now we have one entity remaining, which is ingredient. Can write it here, ingredient with name as primary key and calories. Okay, let's see the relationships. First, we have a relation here, one to many. As mentioned in the previous tutorial, in the relation one to many, we have two options, either to make a new relation and putting the two primary keys as foreign keys and choosing the primary key of the many to be the primary key, or taking the primary key of the one-sided and put it in the many-sided. So in this case, we are going to take the primary key of the main dish and put it in menu. So here we can add the primary key of the main dish, which is name. So we can call it m.name, for example, make it a foreign key, and stating that menu dot m name references main dish. Okay, so here we mapped this relation. This is the first one. The second relation is many to many. Simply we can make a new relation, for example called consist of or anything, and put the two primary keys together, which is menu.id and the primary key of the side dish, which is s.name, and both will be the primary key together. One references the menu and one references the side dish, and we have to state here each one references who. And last but not least, this relationship, which is a many-to-many relationship between menu and ingredient, we can call it, for example, R3 or anything, and put the two primary keys together, which is m.name and I.name. Both will be the primary key together, and we have another attribute, which is the grams. It's an attribute related to the relation itself. So we have to put it in this relation and state each one reference who. Okay? The next example is the same like the previous one. We have more entities with more relationships, and we have an EERD where the C is a subclass for two superclasses, A and B. Let's start with the entities, okay, that where there are no inheritance with it, okay? Let's start, for example, with F. In F, we have two attributes. One, F1, which is a composite attribute, where it is defined or it is consists of two different attributes, F1, 1 and F1, 2. We can simply represent these attributes in two different columns, F1-1, F1-2. Since the composite attribute is the primary key, so both together will be the primary key. And we will have F2. Okay? Next, we have a relation E, where we have E1 and E2. Okay? Now we have relation C, which is a subclass for two superclasses. How we are going to represent these entities? We can make simply a relation for each entity. So here we are going to have A with A1 as a primary key, okay? And since A2 is a multi-valued attribute, so we need to make another relation in order to represent the multi-valued attribute. So in this case, we are going to have, for example, another relation called A1 with its primary key, which is A1, and the multi-valued attribute, which is A2, and both together will be the primary key, where A1 references A. So we have to state that A1 dot A1 references A. Okay? Next, B. B1 as a primary key and B2. Okay? Next, C. In C, we do not have a primary key because the primary key could be either the primary key of A or B, since C is a subclass of two different superclasses A and B, where we have a union. The union indicates that C could either be A or B. It cannot be A and B at the same time. Okay? So for example, C could inherit attributes from A or from B once at a time. In this case, in order to relate the subclass with the superclass, we introduce something called a surrogate key. What is a surrogate key? It's a key for the subclass C, which will be the primary key, and this key will be a foreign key in each superclass in A and B. So, as if we are going to make a key or a primary key for C. Okay? So, for example, let's call it CID, and this will be the primary key, C1, C2. In this case, in order to relate the relation or the inheritance between A, B, and C, we need to add the primary key or the surrogate key which connects the entities with each other in each relation. So in this case, in A, we are going to add CID, which is a foreign key, reference C. Here we are going to state A.CID references C. And the same goes in B. We are going to say CID, okay, and state that B.CID references C. Okay, now we are done with mapping the inheritance between these three entities. Let's continue. We have here a weak relation between B and D, where D is considered as a weak entity for B. In this case, we make a relation for D, okay, and we use its primary key combined with the primary key of the parent, which is B, together to be the primary key of the relation, stating that B1 references the B, okay, D2. However, here we have a multi-valued D3. In this case, we make a new relation in order to represent this multi-valued. So we are going to make a new relation, D1 for example, adding the primary key of the D, which is both keys together, D1, B1, both as a foreign key and primary key, and add D3 with it. Okay? Now we are done with all the entities. Let's describe or map the relationships. Here, between A and F. Sorry, we still didn't... sorry, the F is here, yes. Let's map the relation between A and F. It's a one-to-many relationship. In this case, what we can do is putting the primary key of the one-sided, which is F, in the many-sided entity. So here in A, we can add the primary key of F, which is F1-1, F1-2, as a foreign key. Now we mapped this relation. Let's move to another relation, which is A-B, many-to-many. Simply we can do this by relation called AB, adding the primary key of A, the primary key of B, both together as primary keys, and both will be foreign keys. And we have to state clearly each attribute reference which entity. Okay? Now we are done with this relation and this one. Let's move to this relation. It's a many-to-many self-relation. So in this case, what we can do is a new relation. Since it is a many-to-many relationship, we can make it double E, E1, E-1, for example. Okay? Both are primary key and both are foreign keys. Each one references E. It's a self-relationship. Okay? And the only relation missing is the relation between E and D. It's a one-to-many relationship. So simply what we can do is put the foreign key of the one, which is D, in the many-sided. So in E, here, we can add the primary key of D, which is D1 plus B1, because the primary key of the weak entity is both the primary key of itself and the primary key of its parent. So in this case, in E, we will have B1 and D1, both as foreign keys and both references the D. Okay? Let's move to another example. Okay, let's solve exercise number 6 in practice assignment number 4. Okay, let's see the entities we have. We have employer, trainee, where trainee can be either employed or self-employed. So we have two subclasses. Course, and it has a weak entity, which is addition. Instructor, which could be either full-timer or freelancer. And last but not least, seminar, and the relationships between the entities. Okay? Let's start with the simple entities. We have here the course. Okay, the course has a number and title, so we have course with number, title. Okay, and edition, which is a weak entity for course. So in this case, the edition will have a primary key, start date and date, which are the primary keys of edition, plus the primary key of the course, which is the number. Okay, so here we have edition with start date, end date, number, which is a foreign key, and the three together are the primary key. And here we are going to state that edition dot number references course. Okay, next we have an instructor with two subclasses, full-timer and freelancer. The simplest way is to make a relation for each entity. So in this case, we are going to have a relation instructor with its attributes, which is the primary key, the pass num. A composite key name consists of first name and last name. We can separate them in two different columns. And phone, which is a multi-valued. So in this case, we need to make another relation for the phone. So we are going to have instructor phone, for example, adding the primary key, okay, as a foreign key, and the phone. Both together are the primary key of this relation, and pass number references instructor. So we have to state that instructor phone dot pass number references instructor. Okay, next we have full-timer and freelancer. So we are going to make a relation for each one of them. Full time, we are going to take the primary key of the superclass, which is the instructor. So we are going to have the pass name as a foreign key and the primary key with the rest of the attributes, which is in this case the salary. Take care that we need to refer the foreign key after each relation. So in this case, we have to write that full-time dot pass name references instructor, and the same goes for freelancer. We'll have pass name or pass number, sorry, as a foreign key and primary key with the pay rate. Okay, let's try to map the relationships in this part. In this part, we have a relation between course and edition, which is one to many. So in this case, we are going to put the foreign key of the one-sided, which is course, in the many, which is already done here when we represented the weak entity. Okay, next we have a relation between course and instructor, and it is a many-to-many relationship. So we can make course instructor and put the two primary keys together, which is pass number and number of the course. Both are primary key, and we have to state each one, reference which entity. Okay? Next, we need to make this relationship, which is a one-to-many relationship. In this case, we put a foreign key of the one-sided, which is instructor, in the many-sided, which is addition. So we are going to put the primary key of the instructor, which is the pass number, and the foreign key in addition. So here we are going to add pass num, which is a foreign key, and we have to state that this attribute references instructor. So now we have already done the mapping of this part. Let's move to the other part, which is the employer, trainee, and the seminar. Okay? Seminar has date, place, time, and the three together are the primary key. Okay? Next, we have trainee. The trainee could either be a self-employed or employed. Okay, the easiest way here is to make a relation for each entity. So let's start with the superclass. Trainee. We have here ID, which is the primary key, age, which is a derived attribute, and we have to state this here, name, which is a composite, first name, last name, gender, and last but not least, DOB. We have a phone, however, the phone is a multivalue, so we need to make it in a different relation. So we can say trainee phone, taking the primary key as a foreign key and adding phone, and both will be the primary key of this relation. Okay? Next, we have the employed, which is a subclass from the superclass trainee. Okay? So, employed will take the ID from trainee, which will be the reference key, the foreign key, sorry, and the primary key as well. And we have self-employed with ID as a primary key and foreign key, and area of experience. Okay? Next, we have the employer, okay, where its primary key is the name, and it has two other attributes, which are the address and the phone. So we will have here employer with name as primary key and address. Since phone is a multi-valid attribute, so we are going to represent it in a different relation. Employer, phone, taking the primary key as a foreign key and adding phone, and both will be the primary key together. Okay? Now, let's start to map the relationship between these attributes: employer, employed, self-employed, trainee, seminar, and if there are any relationships with this part. Okay? Let's start with employer and trainee. It's a many-to-many relationship. So we are going to take the primary key of the trainee and the primary key of the employer and put them together in a relation and check if there are any other attributes related to the relation itself. The relation is called used to work for, so we can call it work, for example. Take the primary key of trainee as a foreign key and take the primary key of the employer, which is name, as a foreign key as well, and both together will be the primary key of this relation, adding the attributes which are found on the relation itself, which is the start date and date. So now we are done with this relation. Let's move to another relation, which is employer and employed. It's a one-to-many relationship. So in this case, the easiest way is to put a foreign key of the one-sided entity in the many-sided. So in other words, take the primary key of the one-sided and put it in the many-sided, which is employed. So here we can take name, which is the foreign key of employed, and put it in the many-sided, which is employed. Now we are done with this relation itself. However, here we have two attributes that are related to the relation itself. We can simply add them here as well. So we can add position as date. So either to take all the attributes related to the relation with the primary key of the one-sided and put them all in the many-sided entity, or to make a new relation. Both are acceptable. Okay? So we are done with this relation. Let's move to the other relation, which is trainee addition. It's a many relationship. So we can, for example, state a relation called attempt. Take the primary key of trainee, which is ID, as a primary key, and as a foreign key, and the primary key of the addition, which is a weak entity. So its primary key is the primary key of addition plus course. So in this case will be start date, end date, and number. The three together are the primary key of addition, and the three together are foreign key referencing addition. So this relation will have all these attributes as primary key, which is attempt. Okay, so now we are done with this relation. We have an attribute related to the relation, so we should add it as well. Okay, let's move to our last relation, which is seminar related to addition. It's a many to one relationship. So in this case, it's not clear here that it is one actually. So in this case, we can take the foreign key of the one and put it in the seminar, which is the many, or make a new relationship. Both will be correct. Okay, in this example, we will have different type of question where we are going to give you the relational schema, and you should deduce the right or the correct EERD that should be obtained from this relational schema. Okay, we have A, B, C, D, E, R, T, where the foreign key are denoted by using the same attributes. So for example, if I want to indicate that A1 is a foreign key, it will be found in another relation again. It will be repeated. So in this case, it's a foreign key here in R, and it's a foreign key here in T, and so on. So this is the way to indicate whether the attribute is a foreign key or not. If you found that the attribute is repeated, then it is a foreign key. So now we have A with A1, A2, A3. So simply we have entity A with attribute A1, A2, A3. Okay, we have another entity which is B with B1, B2. We have another entity which is C. However, here the C consists of three attributes: B1, C1, C2, where B1 is actually a foreign key referencing B, and both together are the primary key of this relation. In this case, if we have a foreign key that is a part of the primary key of the relation, it could be one of two options. Either this is describing a relationship between C and B, or this is a weak entity for B. Okay? Since C has another attribute which is C2, and C1 is a new attribute that is not found before, so it is not repeated, so it is not a foreign key, which means that C is an entity that has C1. However, C1 alone is not enough to identify this entity, which means that C is a weak entity to B. So in this case, you will have C as a weak entity with C1 and C2. Okay? And we have to indicate the weak relationship between these two entities. Next, we have D, which has an attribute D1. So, since D1 is a new attribute that was not found in the previous relations, so this is a new entity called D, its attribute D1. E, that has E1, E2, E3, and E1 is the primary key, and all the attributes were not found before, which means that E is a new entity. So we have here E with E1, E2, E3. Now we are done till this step. We have now R with A1, D1, E1. The three attributes were found before, which means that R is not an entity. Simply R is a relationship connecting three different entities, which are A, D, E. So we have here a ternary relationship between E, D, and A. How to know the cardinality of this relationship? The many-sided entities will have the this relation, the primary key of this relation will be the primary key of the many-sided entity. Since the primary key here is D1 and E1, so D and E are the many-sided, and the E is one-sided. Okay? Here we have relation called T, because the primary key is consists of A1 and B1, where both were shown before in the previous relations. Okay? So now we have A1 and B1. So this is a relation between A and B. And the primary key is the key of both A and B, which means that both are many-sided. However, we have here an attribute T1, which is a new attribute, and it is not a part of the primary key, which means that this attribute related to relation T only. So it's an attribute on a relation. Okay? So, to summarize what we took this tutorial, we took how to map the relation, how to map the EERD to a relational model, we have three options of mapping the EARD, either to neglect the superclasses and make a relation for each sub and adding the common attributes in each one of them, or to make a one universal relation and put all the attributes together, or the simplest way is to make a relation for each entity. Okay, however, in this case there will be a lot of crossing referencing because the primary key will be of the superclass will be a foreign key in each subclass. Okay, we have mentioned before that there are many ways to map the relationships between the entities. If it is one-to-one relationship, we could either include a primary key of one of the entity as foreign key in the other, or merge the two entities together or make a new relation. If it is 1 to n, we have two options, either to make a new relation, making both primary key and choose the attribute of the many-sided to be the primary key of this relation. So the primary key of the relation will be the primary key of the many-sided, or to put a foreign key of the one-sided in the many-sided entity. And in the n-to-n relationships, we make a new relation, taking the two primary keys of the entities as foreign keys, and both will be the primary key of this new relation. Okay, some attributes should be mapped in a special way. For example, the multi-valid attribute. If we have the number of the values, for example, if we know that the employee, for example, has only 2 phone numbers, we can just add 2 columns. However, if we don't know, we have to make a new relation, taking the primary key of the original relation as a foreign key in this new relation, and adding the multi-valid attribute, and both together will be the primary key. The composite key, which is the composite attribute, which is an attribute that consists of different parts, could be either added as different parts. For example, as we mentioned in this tutorial, if we have name that consists of first name and last name, we can just neglect name and put 2 columns, first name and last name, and some put 1 column only called name, and they put the whole string in this column. However, in this case, there will be some complexity in manipulating the string itself if we want to search for a specific name. Okay, next tutorial we are going to move to another topic, which is the relational algebra. So take care, and if you need anything, just contact me or send me an email. Thank you very much.